Two separate teams in China just built two separate lasers that both do something ASML's own CEO said, on a live investor call, would take China many, many years to pull off. One of those teams is led by a scientist who used to run this exact research inside ASML itself. And neither team knew at first that the other one existed. That's not the twist. That's just the setup. The actual twist is coming in about 90 seconds, and it changes what "monopoly is over" really means here. So don't check out early on this one. Here's the fast version first. In 2025, a team at the Chinese Academy of Sciences built a working laser system that generates real EUV light, the same wavelength ASML's machines use, using a completely different method than ASML does. Separately, a team at Harbin Institute of Technology built a second, entirely different laser using yet another method, and it also worked. Two independent breakthroughs, two different physics approaches, landing inside the same 12 months, inside the same country, aimed at the same monopoly. Now for the part that should genuinely stop you. Every single advanced computer chip made on Earth right now, the processor in your phone, the servers training the world's biggest AI models, depends on a machine that only one company has ever known how to build. ASML, in the Netherlands. Not the market leader. The only company that's ever shipped one that actually works. In April of this year, ASML's own chief executive, Christophe Fouquet, was asked directly about China's progress on an investor call. His answer, word for word, was that it's always possible to generate some EUV light, but it would take China many, many years to actually build a working machine around it. That call happened in April. The paper proving China had already generated real, usable EUV light was published the month before. Let's actually get into how they did it, because this is where the story gets genuinely interesting, and where most coverage of this stops being accurate. ASML's machine works by firing an extremely powerful carbon dioxide laser at tiny droplets of tin, thousands of times a second, vaporizing each droplet into a plasma that emits the exact ultraviolet wavelength needed, 13.5 nanometers. It sounds almost violent when you say it out loud, and it kind of is. Each droplet is smaller than the width of a human hair, and the laser has to hit it twice, once to flatten it into the right shape, then again to actually vaporize it, all happening 50,000 times every single second, with nanometer-level timing precision. That process alone took ASML the better part of 3 decades and somewhere around $8 billion to perfect. The Chinese Academy of Sciences team, led by a scientist named Lin Nan, didn't copy that approach. Lin previously worked at ASML, specifically inside its light source division, before returning to China in 2021 as part of the country's talent recruitment push. Instead of a carbon dioxide laser, his team drove their system with a solid-state laser, a completely different kind of light source, and reported a conversion efficiency of 3.42%. Here's why that specific number actually matters. Conversion efficiency is how much of the energy you put in actually comes out as usable EUV light. ASML's commercial systems run around 5.5%. Even the top research lab in Europe working on this exact problem, the Advanced Research Center for Nanolithography, had only reached 3.2% as of 2019. Lin's team beat that European benchmark using a fundamentally different laser design. But hold that thought for a second, because there's a second team you need to know about, and this is the part that gets confused constantly online. At almost the same time, a completely separate team at Harbin Institute of Technology, led by a professor named Zhao Yongpeng, built their own EUV light source using yet another method entirely, called laser-induced discharge plasma. Their approach vaporizes tin between two electrodes instead of hitting droplets directly, and it reportedly hit somewhere between 100 and 150 watts of actual power in the middle of 2025. That project won a Provincial Innovation Award, described by the institute itself as low-cost, compact, and relatively simple compared to Western methods. So here's the actual headline underneath the headline. This isn't one unified Chinese breakthrough. It's two competing Chinese teams, using two different physics approaches, both independently proving that a domestic EUV light source is technically possible. In the same 12-month window that ASML's own CEO was telling investors this was still many years away. Think about how unusual that actually is for a second. Most technology breakthroughs you hear about come from a single lab, a single funding stream, a single research direction that either works or doesn't. This is two entirely separate institutions, in two different Chinese cities, pursuing two fundamentally different laser physics, without apparently coordinating with each other at all, and both crossing a threshold that Western analysts assumed was still years off. That's not a lucky single roll of the dice. That's what happens when a government treats a specific technology gap as urgent enough to fund multiple competing bets on it simultaneously. Now, before we go further, if a story like this, one where the actual nuance matters more than the headline, is the kind of breakdown you want more of, this is exactly what this channel does every single week. And subscribing now means the next one lands in front of you the moment it happens, not weeks later once everyone else has already talked about it. Let's talk about what "world's first" actually means here. Because the title of this video, and honestly most headlines covering this story, oversell one specific detail. ASML has been generating EUV light commercially for over a decade already. What's actually new isn't the existence of EUV light. It's China proving it can generate that light domestically, without relying on a single component from the company that's held this monopoly since the technology existed at all. That's a real distinction, and it's the one almost nobody explains clearly. Here's the honest scorecard. Because both the ASML's finished panic and the "this changes nothing" dismissal are wrong, and they're wrong for specific, checkable reasons. What's true? Lin Nan's team hit 3.42% conversion efficiency, genuinely ahead of comparable European research at the Advanced Research Center for Nanolithography. What's also true? Commercial systems need 5.5% to be viable, and Lin's own team says their theoretical ceiling is around 6%, meaning they're close on paper, but haven't actually built anything running at that level yet. What's true about Harbin's laser? It hit 100 to 150 watts, and the institute itself describes the approach as low-cost, compact, and easier to manufacture than Western methods. What's also true? High-volume commercial manufacturing needs over 250 watts, sustained, reliably, for years without failing. Neither Chinese team has built a light source that can actually run a real chip factory. Both of them have proven the physics works. Those are two very different sentences, and the gap between them is exactly where this story actually lives. Here's the part that makes this different from just another lab result, though. A working light source is genuinely the hardest single piece of this entire machine to get right from scratch. Everything else around it, the mirrors, the wafer stage, the vacuum chamber, all of that is difficult, expensive, precision engineering. But the light source is where the actual physics fight happens, and it's the piece most Western analysts assumed China was furthest behind on, specifically because ASML spent 30 years and $8 billion just getting its own version reliable. Having two independent teams clear that specific bar, using two different methods in the same year, is not a small result, even if it isn't a finished machine either. And here's where it gets stranger still. Reuters separately reported that a fully assembled prototype EUV machine, not just a light source, an entire working system, was completed in a classified facility in early 2025 and is currently being tested. That team reportedly includes former ASML engineers as well, and it's unclear whether Lin Nan himself is even connected to that specific project, or if it's a third, entirely separate effort. 3 programs, possibly overlapping, possibly not, all converging on the same monopoly, from different directions, at roughly the same time. Here's why that specific detail changes how you should think about everything else in this video. If these were 3 isolated, disconnected projects that each happen to succeed independently, that's actually more concerning for ASML, not less, because it means the barrier they spent 30 years building isn't nearly as singular or defensible as everyone assumed. A wall that only one team can climb is a real wall. A wall that 3 separate, uncoordinated teams all manage to climb around the same time isn't really a wall anymore. It's a problem that was simply waiting for enough resources and enough motivated engineers to get thrown at it. So is the monopoly actually over? Here's the straight answer. No hedging. No, not yet. And probably not for at least a few more years. China's own internal targets reportedly point toward 2028 for something closer to production-capable hardware. Independent analysts, including researchers who specifically track this exact industry, put the more realistic window somewhere around 2030 for pre-commercial tools, with full production competitiveness likely not arriving until 2032 or later. ASML, meanwhile, isn't standing still either. It shipped 61 EUV systems last year alone, and currently holds a backlog of more than 90 orders worth over 13 billion euros. That's not a company watching its position evaporate. That's a company with a multi-year head start and a full order book. But here's why none of that actually makes this story small. Every previous China is catching up story in this industry has been about copying, buying, or reverse engineering somebody else's finished machine. This is the first one that's genuinely about parallel invention. 2 different Chinese teams solving the same fundamental physics problem 2 different ways, independently, and both getting real, measurable, published results that beat existing European benchmarks. That's a different category of threat than a smuggled chip or a second-hand machine taken apart in a warehouse. That's an actual research base capable of closing a gap ASML took 3 decades to build, potentially in a fraction of that time. Watch the conversion efficiency numbers over the next year, because closing that gap from 3.42% toward 5.5% is the single number that actually determines whether any of this becomes commercially real. Watch whether these separate Chinese teams start combining efforts instead of racing each other, because right now, resources are still split across at least 2, possibly 3 competing approaches. And watch how ASML responds on the talent side, because a company that already lost one of its own light source scientists to this exact effort has to be asking itself who else on that team might be next. There's also a supply chain angle here that barely gets mentioned, and it's worth understanding before you decide how big this story actually is. ASML doesn't build every part of its own machine either. The mirrors come from Zeiss in Germany. Critical precision components come from suppliers across Japan, the United States, and a handful of other countries. ASML's real advantage was never just one laser. It was 30 years of coordinating an entire global supply chain of specialists who all had to solve their own individual, nearly impossible problems at the same time. China proving it can solve the laser piece is genuinely significant. It still hasn't proven it can solve every other piece of that chain simultaneously, at commercial reliability, all at once. That's the difference between a breakthrough and a monopoly actually ending. Think about what happens if China does eventually close this gap, though, because the consequences reach further than just cheaper chips. Right now, the United States has leaned on ASML's monopoly as one of its most effective tools for slowing China's military and AI ambitions, precisely because you can't build cutting-edge chips without this exact machine, and there was only one company on Earth willing to sell it. If that single point of leverage disappears, an entire category of export controls that Washington has relied on for years loses its teeth overnight. Not because the policy changed, but because the physical choke point the policy depended on stopped being a choke point at all. That's the actual stake sitting underneath every one of these laser efficiency numbers. It's also worth being honest about why two competing Chinese teams are racing each other, instead of one unified national lab quietly working through this methodically. Reporting on China's broader chip strategy suggests this is intentional. Several parallel efforts funded simultaneously, on the theory that betting on multiple approaches at once increases the odds that at least one of them reaches commercial viability first, even if it means duplicated spending and overlapping research. It's a more expensive strategy than picking one horse and fully committing. It's also, historically, often a faster one. And it's the same approach that pushed China's solar panel and battery industries from behind to dominant within a single decade each. So here's where this actually leaves us. Two lasers, two methods, two teams that didn't know about each other when they started, both landing real, measurable, independently verifiable results in the same 12 months. A monopoly's own CEO told investors this was still years away. Not a finished machine. Not a monopoly that's over yet. But the single hardest problem in the entire chain, solved twice, independently, faster than almost anyone outside these two labs expected. If you want to actually understand what happens next here before it turns into another oversimplified headline, that's exactly what's coming on this channel the moment the next number moves. And that's usually faster than people expect in this particular race. Drop one word right now before you close this tab. Ignited, if you think this genuinely starts the countdown on ASML's monopoly. Inflated, if you think the 5.5% gap is bigger than this story wants you to believe. Type it now, then go watch exactly how close China's mirror technology actually is, because that's the piece that decides whether any of this laser progress ever turns into a real chip.